Okay, so our next topic we are having, that is center of mass after the state of equilibrium. So in this video we'll discuss about center of mass and center of gravity too, and how to calculate the center of mass. Okay, so first of all, what is center of mass? Center of mass is basically a point where the body is equilibrium state, or at a stable state, or you can say a point where the whole mass is act on, or you can say a point where the whole mass is distinguished on an equal, you can say, on the body, which is called the center of mass. For example, you can take the example of the watch. Okay, clock. So this is what, here you can see that this all the mass is distinguished between the one point. Okay, so this is the center of mass, as well as you can take the example of a triangle, which is, this is what is the center of mass. If we talk about this, for example, this is the LED, and this is what, this is the center of mass. Okay, you can take the example of any this thing. So this is what, this is the center of mass. Okay, so this is the center of mass. But one thing that I want to tell you guys, as compared to the MCQs, which is that center of mass that do not depend on gravity. Okay, or you can say the intersecting point on a center is called center of mass. There are many definitions, and if we talk about the unit, so that is meter. Okay, for example, there we are having a, here we am having a box like structure, and here the matter is more, like mass is more. Okay, center of mass is here, but here the mass is more, so the center of mass will be here. Okay, so this will be calling as a center of mass because of the more weight. Where the weight will be more, so the center mass will be more. Where the weight will be less, lighter mass, so there the center of mass will be less. Okay, so both center of mass and center of gravity is different. So if we talk about the center of gravity or weight, that basically depend on the gravity. This is basically occur when there is gravitational field. Okay, if we talk about the definition, which means the point where the whole weight is acting on a body is called the center of gravity. Okay, whole weight. Here we are talking about whole mass. There is a huge difference between mass and gravity. Weight, because gravity weight is, you can say that W is equal to mg, which means mass and gravity. So here we are having the gravity. So we are having a, for example, we are having an object. We are having this one ball on a finger, and here we are having a ball but at the side of a finger. So this ball will be attracted to the gravitational field, so we are calling that as a center of gravity. Okay, so if we talk about the center of mass and center of gravity will be equal when there is the uniform gravitational field, or you can say at the earth surface. For example, I'm having this one as a tire on a earth surface, as well as this one as a ball on earth surface. So this will be having a center of mass, this will be having a center of gravity, so that will be both equal. Okay, that will be remain same when there is the uniform gravitational field. For example, this ball, I'm having a ball up on the height, on the, you can say that on many height. Okay, 200 height, and this is on the, you can say that on the surface. Okay, so this one will be the gravity of mass will be different, center of mass will be different when this both are at the surface, earth surface. So we are calling that will remain same when the uniform, there is a uniform gravitational field, so we are calling that as a, then the center of mass as equal to the center of gravity. So this is about the center of gravity and the center of mass. Okay, One more thing that I want to tell you guys is that how you can calculate the center of mass with a formula we are having. That is basically a formula we are having. So if we talk about the formula, so for example, this is the y direction, this is the x direction, and here I am having the mass 1. Okay, here I am having the mass 2, mass 1, mass 2, and here we are mass 3. And if you talk about the radius, so this is the distance of the radius 1 x side, this is the distance of x2, this is the distance of the x3, mass 2, mass 3. So we are denoting xcm, which is called, we have to find the distance of the center of mass of the x, because x distance is there. So this is center of mass of the x. So here I can write here m1 plus m1 x1 plus m1 x1 plus m2 x2, m2 x2 plus m3 x3, m3 x3, and in the here we are having the masses m2 plus m3. Okay, so here you can see that we can write here that xcm is equal to the sum of all the mass of the, you can say that the distance, sum of all the mass distance, and here we are calling as the sum of all the masses. Here we are counting all the sum of distance, here we are calling as the sum of all the masses. So this is the sign of the sum of all the forces or anything. So this is the formula through which you can easily find out the center of mass. So this was about today's lecture. We have discussed about center of mass, center of gravity, and the formula how to calculate the center of mass.